Hello everybody, my name is GP and in this video we are gonna see how to use an LCD with a protocol I2C with a PIC microcontroller. Okay, for this we are gonna need to have the Mplab XID installed, also the MCC tool. For install this tool, just go to microchip and search of search for MCC, and there you can see many ways to install this tool. So that's all. Okay, I'm gonna use the microcontroller PIC16F18446. You can use the microcontroller wherever you want. This library is made to be used with whatever PIC that supports the MCC. Okay, so if you got this library and you got a different model PIC, you can use the same library with the same code no matter what PIC you have, if this PIC is supported by the MCC tool. Okay, so keep that in mind. Okay, so the first thing you have to do is create a project. So let's start standalone project. Okay, right here you put your model. In my case, my model is 16F18446, and the tool I'm using a PIC to program this project because I have the circuit already made. Important, we are using the XC8 compiler. We are not using micro C, or we are not using a different compiler. So make sure you, if you are watching this video, make sure that you're gonna use the XC8 compiler. Okay, and right here we put the name we want. I'm gonna put LCD-I2C and the PIC model to remember which PIC model I use when I create this project, and we just click on finish. Okay, that's it. The first thing we have to do is add some files. Okay, the library has 4 files. I will show you those files right now. These are the 4 files. So with those files, we are gonna make the communication between the LCD and the microcontroller. Okay, so it's very important to download these files. I'm gonna let you a link on the description of the video to download those files. And the only thing you have to do is just go for your project. This is the project in which we are working right now, and paste. Okay, so the next step, going back to the Mplab XID, we have to add those files here. Like you can see here in the header, we have to add the header files. There are 4 files, 2 header files and 2 files have to be here in the source files. Okay, so first let's add the header files. We just right click, go to add existing items, and we can see in the end has an H, so we have to add both. Just click one, then control and another one, and right here we have the 2 files, and that's it. Okay, the next thing we have to do is in source the another 2 files. Okay, just this one and this one. Okay, yeah, once we have the files on the correct folders, we have to open our MCC. Okay, we just have to click and wait for a little bit. It's gonna take for a while doesn't matter if you have a great PC. Most of the times take a little bit more when it's the first time you open that on a project. Okay, like here, save, and that's it. First, I'm gonna configure which is my system module right here. I'm gonna use 4 megahertz. Currently, I'm using 1 megahertz, so I'm gonna move this to 32, and I'm using 8 megahertz. That's what I wanna use. You can use whatever megahertz you want. Just I'm using the internal in OSC. So if you want me to explain you how to configure that, let me know down in the comments, and I'm gonna make a video specifically of MCC. I'm gonna take this out, and I'm gonna disable the master clear because I don't like to work with it when I'm just doing some practice video. And okay, right now this is the interesting thing. We have to go to MSSP. This is one module and this is another module. Okay, so in each module we have two libraries. This is the normal of microchip, and this is the foundation services. For this specific library that we are using, we need to use the foundation service library. In case you wanna use this one, you can, but it's not gonna work. You have to modify the files that I leave you. Once you modify those files, you will be able to use this one. But just right now, like I let you those files, you have to use foundation services. Okay. We have to enable SPI or I2C. Like we know, the LCD works with I2C, so it's gonna be this one. The clock frequency, we have to make sure the clock frequency has to be above 100 kilohertz. If the clock frequency is over 100 kilohertz, the LCD is not gonna work. The LCD needs the clock frequency above 100 kilohertz. Okay, so I will leave you that in 100 kilohertz. And for make this job easier, we are gonna use foundation services. Click in here, and we have to look for I2C simple. Like you can see, it's gonna add I2 simple and it's gonna add I2C master. Like you can see, the clock frequency has to be the same. It's not matter, and it's as easy as that. Okay, like you can see, we did like 4 clicks, and that's all. We have enabled the I2C protocol, and the libraries are gonna be created for the MCC. It's so easy. So just right now, we could select the pins we want. In my case, I can. Sometimes you are not able to do that because all depends of the microcontroller you are using. I'm using wait. Okay, I'm using this microcontroller. It's not the newest, but it's relatively new, so I can move the pins. Like for example, I want this SCL, I want it here, so I can move it. If I want it here, I can move it. So if you wanna move those pins, you could do that right here easily. Okay, next step, you use generate. Once it's done, we can close the MCC tool just clicking right here. Okay, so going back, as you can see, it creates us some files. These are the files, libraries, and these are more files, but forget about it. You're not gonna use it right now. Just open the main and go here. Okay, like you know, when we are using the I2C protocol, we need to enable the global interruptions, and we need to enable the peripheral interruptions with this with the MCC is so easy. Just we have to uncomment those lines as CC has that, and that's it. Now we now start using the LCD. Okay, for that we have to go to these header files, and the first thing we have to do is start the LCD. Okay, so we just copy and paste, take out this void, and that's it. That's all we need to do. But like the microcontroller starts too fast, we need to put a delay to wait until the LCD starts, because the peak obviously is faster than the LCD. So the peak is gonna start sending for the I2C protocol of communication data before the LCD turns on. So we have to wait half of a second until the LCD wakes up. Okay. Okay. So the next thing we have to do is to add the we have to include those header files here. Okay. For that we just have to write include. Sorry. Include. We click Control and space, and yeah, like you can see there are our both files. Include again, you can see. Okay, and we are going to include another one for the future std.h and include std.lib.h. Okay, we have to include those libraries, because if you don't include those libraries, the main file is not gonna know what are the functions that we are gonna use to move the library itself. Okay, so you have to do that. For put one example, I'm gonna put the simple stick, a simple thing. Right here you can see all the functions you can use. Like you can see, I'm gonna use this one because it's easier. You just have to put the line and the column in where you wanna write something. You can see line, column, and the message. It's so easy to use. Like example, okay. So I want to write in the line one, on the column one, and I want to write hello world. Hello world. Okay. That's it. Before I program the peak, I'm using my picket, and I don't have a power supply for my project, so I'm gonna put 5 volts directly to the picket to my project. It's so easy. If you want to project, okay, just click right click here, properties, go to picket, power, enable this, and click OK. With this, the picket is gonna supply, is gonna act like a power supply for our circuit. Just wait a little bit, and let's see if it's compiled. Wait. Okay, once it's done, we just program our peak. Okay. Okay. Now what happens if you want to write, I don't know, some int value, float value, long value, or anything else? This library does not let you write here. If you put, for example, let's put example, okay? You want to write a float called GP equal to, I don't know, 20.2. Okay, if you write that right here. It's not gonna compile because it's a mistake. You have to put here just a string in case if you don't want to put if you don't want to write something, you have to put here for example a string, and this is not a string, this is a float. So what you have to do is use this function printf, and with this function you can convert those float numbers or log numbers in numbers into a string and add some letters if you want. I'm gonna put you an example, okay? If you want with a string here, this is the structure. First you have to put the string in which the data is gonna be saved, okay? So here str, this is the string. In the middle we have to put the text, like for example hello world. That's okay. And in the last one we have to put the variable gp, which is gonna be graded on the LCD. And where is this gonna be graded? Wherever you want. In this example I'm going to grade it there, so I put this. What does it mean? The LCD is gonna grade hello world. This means that it's gonna be a float variable, and that one means that I just want one number next to the point, because if I point this, that means that I could write 20.2. This is what is gonna be graded on the LCD, but like I just put this, the LCD is just gonna grade that. That's what I want. And the last thing, we need to put str. We need to declare that, because right now it's undeclared. So it's gonna be a string. Str 10, whatever number, has to be more. The number has to be more than the number of characters we have here, like 1 2 3 4 5 6 7. I don't want to count that. I just put 20. Is more than what we have here, obviously, so it's more than enough. Okay, so we are ready. Just compile. Yep. And once it's done, just let's go to program. Yep, like you can see in the picture, it writes hello world 20.2. What means that was prediction was correct. Obviously it cannot write more zeros because the end of the LCD is there, but doesn't matter. If I will put this one in our position anyway, it will just write 20.2, because that's what we program here. So that means if you have the library, it's gonna take you just like 3 minutes to make the LCD works. I mean, the video is too long because I need to explain every part of this how does it works, but you can make the LCD work in just 3 minutes. It's an easy way to have an LCD and fast way to program it. Does not spending a lot of time. Okay, thank you for watching, and I'll see you in the next video.